Let's do what we usually do with these problems. When we're trying to find a radius or interval of convergence, we want to use like the ratio or the roots test. Oops, knocked over my mouse there. So if we skip ahead a little bit and we evaluate the limit as n goes to infinity for the ratio test, then it's cosine squared n plus 1 over times x to the n plus 1 divided by cosine squared n times x to the nth power. So when you try to evaluate this limit, then we're looking at it's cosine squared n plus 1 over cosine squared n, and then x to the n plus 1 over x to the n, that's just x here. And for this to converge, we need this limit to be less than 1, right? So if you think about this fraction right here, and the values that can come out of the numerator and the denominator, it's cosine, right? And it's okay that it's being squared. Because cosine is always between -1 and +1, then cosine squared is always between 0 and 1, right? So you've got a number that is at most 1, and then you've got a number down here that's slightly different because it's not n plus 1, it's n. But this number is also between 0 and 1. So this ratio at max could be 1, and actually it can never actually equal 1. It can get close to 1, but this fraction right here, the biggest it can be is 1. So if we need, that would be evaluating the limit as n goes to infinity, okay? N keeps getting bigger and bigger, but they keep oscillating between 0 and 1 in the numerator and the denominator. So what that means for x is that x has to be a number that is between, it could be, let's see, yeah, it could be -1 or it could be +1. Anything bigger, and then this ratio would be bigger than 1, right? So x needs to be between -1 and +1. Because if it's anything bigger, if x equals 2, for instance, then 2 times 1 would make 2, and that would be greater than 1. So it wouldn't converge by the ratio test. Okay, so this is a tricky one because there's not like, actually maybe there is, maybe I just haven't thought of it. I think maybe you could expand using the Pythagorean identities. I don't know, I think it'd take a long time, but it's just, you got to analyze this one just by using what we know about cosine. Cosine is always between -1 and +1, so cosine squared is always between 0 and 1. So at most, this fraction can be 1. The limit as n goes to infinity if this fraction is at most 1. So that means x can be at most 1. Okay? Or since it's the absolute value, x could be -1. Anything bigger, and it wouldn't converge by the ratio test. So that's our interval of convergence. So the center is 0, right? So that means the radius is 1. There's 1 unit away from 0, on either side. The center is at 0, so the radius has to be 1 here.